Hello everyone, welcome back to another video for the series, and I'm Q, and today I brought a problem from IMO, and it's the problem is quite old, so it's even though it's like problem number 6, it was like pretty straightforward, and I'm not saying that like old IMO contests are easy, but like compared to like the modern IMO problems, I think this one was a little more easier than the other ones, and I think that's why I really loved this problem as a beginner who is studying functional equations right now. So, like first up, it's like general rule of thumb, but it's like let um, x equals y equals 0. Like I think we usually do this for all like functional equations. I'm not sure like if unless it is like um something like this, we usually do it. So now notice that if you just write it like this, it will be like way too messy. So let's say and f of 0 equal k. So we have f of 0 minus k, which is negative k, equals f of k plus 0 plus k minus 1. That's what we know so far. And now let's move on to the next one. The next one is, I think, finding like the relationship between the numbers. I mean, like the function. Notice that f of y appears multiple times, and like we have x minus f of y. So like why don't we let this is our first case, and second factor is when case is when let let x equals f of y. Then we have f of 0 equals f of x plus x squared plus f of x minus 1. And great, now we can write f of x equals x squared minus 1, and then this is k, so minus k, like by our definition, over 2. Now notice that f of x is even because f of x equals f of negative x, because we have x squared here, meaning f of k equals f of negative k. So you have f of k equals f of k plus k minus 1. Therefore, k equals 1. Now we can just substitute. So we have f of x equals x squared. Wait, what am I doing? I forgot negative sign here. Negative x squared plus 1. Yeah, sorry about that mistake. I forgot to, So here we have equals 2 minus x squared over 2. And that is indeed our answer. And usually for function like problems involving function equations, we need to prove that this is like the only solution. But I think and then like the common technique that we use is to prove it using if and only if condition. So if this is true, then this is true. Now the converse must be true. So if this is true, then this is true. Then we can find then this means this f of x conforms to the if and only if condition, right? So I think if this Yeah, so that's why we can re-substitute it, right, to prove our if and only if. So we just proved that if this is true, then this is true. Now let's prove like the if and only if. So we have f of x minus f of y equals f of y plus x f of y plus f of x minus 1. Now let's substitute to see if this is correct. So we have our left hand side. I'm pretty sure it should be right because it's just like the direct consequence of it, but like just to prove if and then condition. Now, okay, so we have f of x minus 2 minus y squared. I think this will be way too dirty, but let's just try. Minus x minus 2 minus y squared over 2. Okay, so I think I don't think it will be that bad. So let's just try our right hand side first to see if we have to simplify it further. We have 2 minus y squared over 2 squared 2 minus over 2 plus x times minus x squared over 2 minus 1. So if these two are equal to each other, then we prove it. Like the formal, the IMO official solution did not include this part. It just said that this is like the only solution. So I might make mistake. This is equal to 1 minus 1 over 2 x squared. Wait. Okay, so we have 1 minus x squared minus 2 minus y squared plus y4 minus 4y squared plus 4 all over 2. Now this one is equal to is this minus? Yes. 1 minus y to the 4 minus 4y squared plus 4 over 4 over 2 plus over 2x minus xy squared plus 1 minus 1. We can cancel this term. We can also cancel 2x. So this is positive, negative. So this one and this one. This one and this one, this one and this one. Oh, so indeed they are equal to each other. So meaning if this is true, then this is also true, and if this is true, then this is true. So if this, then that, and if this, then that. So this follows the if and only if condition. Thus, f of x, this one is the only solution. And we completed our, oh wait, we don't need that, it's not a proof. And we completed our solution. So yes, I think I learned a lot from this problem. Even though it was quite, it didn't use like fancy techniques, I really enjoyed this problem as a beginner. And I think the kick here is to notice this one, that f of 1 is even. I mean, f of x is even. And yes, so I really enjoyed it. And thank you so much for watching this video. Tomorrow I'll try to come back with another very fun and interesting problem. And thank you, and see you tomorrow. Bye.